Hello, this is Evie Sanders, and today Monica, Chloe, and I will be presenting our chemistry projects on eggs. Each of us prepared eggs in a separate way, all the while explaining the science behind how they cooked, Monica with boiled, Chloe with fried, and myself with a meringue. If you have any questions, drop them in the comments down below and we'll answer them. And up first, we have Chloe with her fried eggs.
Today, we're going to talk about cooking eggs, preferably dippy eggs. First, we're going to start off by talking about the anatomy of an egg. The yolk, which is the yellow part of an egg, accounts for approximately 1/3 of the weight of an intact chicken egg. Comprised of mostly fats and proteins, it carries 75% of the calories and most of the iron and vitamin A. The white is 90% water, the rest being protein. There are only traces of minerals and fatty material, as well as glucose and vitamins inside. The white provides essential proteins for the human. Next, we're going to talk about the shell. The shell is made of calcium carbonate and protein. The shell is riddled with pores, tiny holes, that allow gases to pass in and out of the egg. Now we're going to talk about the yolk. The yolk made up of about 50% solids, which are proteins, lipids, and carbohydrates. The yolk has twice the amount of lipids as protein in egg yolk. As well, 92% of the yolk is comprised of different lipids. Generally, it takes more heat to cook the yolk in many cases. Now we are going to talk about the white part of the egg. The white is mostly water. The mixture of proteins in the egg white is called albumin. When I crack the egg in the pan, the visible part of the egg white is called chalaza. The egg white has a pH of 7.6 to 9.5. Now we're going to talk about the shell. As I mentioned before, the shell of the egg is made of calcium carbonate and protein. There is a thin protein that covers the eggshell called the cuticle, and this blocks pores to slow the loss of water and prevent bacteria from entering the egg. A cool fact: have you ever wondered why some eggs are brown or white? The reason is it's due to the chicken's genetic makeup that colors the egg. As well, there is no nutritional difference between brown or white eggs. Now we're going to get to the cool part, the cooking of the egg. When a protein denatures, energy in the form of heat added to the mixture of proteins makes the molecules move around. Add enough energy and the proteins move and groove enough to break all the hydrogen bonds holding the A helix and beta sheets and loops together. And the three-dimensional globular protein structure unravels. When the protein unfolds, all the hydrophobic parts that were buried inside the protein are exposed to the watery environment. The hydrophobic parts hate the water, and instead, they like to find another hydrophobic place to be. The exposed hydrophobic parts of a protein join together with exposed hydrophobic parts of other proteins clumping together in a process called coagulation. The unfolded coagulated protein is now a large aggregated complex that can't stay dissolved in the water. So, the coagulated protein solidifies, trapping water molecules between the unfolded proteins. While cooking the egg, you can see that the white is cooked faster than the yolk. The reason is the large amount of fat relative to the protein in the egg yolk makes it that much harder for the denatured proteins to find one another and stick to their exposed hydrophobic parts together. Therefore, higher temperatures are required for the yolk to fully cook. The whites of the egg protein begin to set way quicker, and that is because the proteins are being denatured at a lower temperature.
Today we are meeting with Lindsay Shalabadabadoo, and she will be test tasting our dippy egg today. Lindsay, how do you like your eggs?
I like them different ways. Scrambled's pretty good, so is over medium, or as Chloe calls them, dippy eggs. I also kind of like hard-boiled eggs, but mostly just the white part. But deviled eggs are much better than regular hard-boiled eggs.
I see. Well, we're going to cut into the egg and try it out.
Before I cut it, she did not break the yolk, which was very good because a lot of people mess it up, and then it's not really an over medium egg. It's very thick, which is good.
How's the texture?
It's nice and a little crispy on the edges, which is nice, but it's nice and soft and kind of spongy, which I kind of like in the middle.
And what would you say is your favorite part of the egg? Is it the yolk? Is it the whites?
It's definitely the whites, but I like this one because the yolk is very easily mixed with, and not like super hard and not easy to eat with the other part.
Well, that's good. And out of a scale of 1 to 10, how would you say it tastes?
I give it like a 9.5. It's pretty good. It's better than what I've done. Apparently I suck at making anything.
Well, Lindsay, thank you for test trying my dippy egg today. I hope you enjoyed it and hope you learned a little about making dippy eggs.
Thanks.
Eggs are rich in protein. This protein is the reason why eggs become hard when it's boiled. When you heat the egg, the proteins gain energy and shake apart the bonds between the amino acid strings. This causes the proteins to unfold. When the temperature goes higher, the proteins gain energy to form new covalent bonds with other protein molecules. When the egg boils, the heat causes the proteins to unfold, allowing the proteins to bond with other proteins. As these proteins form new bonds, the water that surrounds each protein is forced out, turning the egg from liquid to hard. So I cracked the first egg, but as you can see, the egg yolk that is coming out is immediately starting to hard because of the temperatures in the water is causing the proteins to rearrange and make new bonds. So you can kind of see it happening, but I'm going to start over and try a new egg. And that one cracked as well, but we're just going to go with it because we're limited on eggs. A failed flip. Got 2 minutes to go for this one.
Yeah.
Okay, so we have been boiling the egg for 5 minutes now, and it's time to take it out and let it cool, and then we can de-shell it and see how the egg turned out.
Then we'll let that cool and we'll crack it up.
Okay, so it turns out we did not let it harden all the way or cook it long enough because the yolk is still raw. But that is a raw egg compared to a hard egg.
A pavlova is a meringue cake, which means it needs a lot of egg whites, and you just gotta beat the egg whites until they're stiff, and then you can bake them. So for this recipe, I needed 4 egg whites, as well as some sugar, some vinegar to help the egg whites proteins denature, and I'll explain more about that later on in the video. But for now, let's talk about how these gooey, clear, liquid egg whites turn into what is an absolutely gorgeous, stunning cake. As we can see here, I'm adding distilled white vinegar to my egg whites to help them denature faster. This works because the vinegar actually alters the pH of the eggs, which helps the proteins break apart from their coils faster. And as you look into the egg whites, you can actually see some little white things floating around in there, and those are actually more protein strands. Those strands were specifically used to help stabilize the eggshell and the yolk inside, as well as protect the embryo. Of course, these eggs were never fertilized, so there was never any embryo. But watch as I start mixing, you can see the egg whites very quickly start foaming up. They start bubbling, they become very frothy, but as I keep mixing, the bubbles begin to go away and the texture becomes more and more consistent as I keep mixing and keep mixing and keep mixing, so on and so forth.
One eternity later.
So what happened where the eggs went from the stringy, gooey, liquidy, clear egg whites to this much thicker, firmer texture? Basically, the eggs are denaturing. This means that the eggs are originally in a coiled structure. The proteins in the eggs are in a coiled structure, and as I keep beating them with the mixer, they're becoming uncoiled. This is also why the egg whites are expanding and becoming much bigger. If you look back to earlier in the video, the egg whites barely cover the bottom of the bowl, and now almost half the bowl is filled. Anyway, as I kept mixing, the texture of the egg whites really smoothed out. It went from a froth to this very smooth, almost Greek yogurt texture, which allowed me to then form it on a pan into a cake-like shape. So after I made the cake into this vaguely cake-like shape, I put it in the oven to bake for about 1 hour. During that hour, I got to sit and get entertained by my adorable little dog who was doing tricks for her favorite type of cheese. Anyway, let's get back to the cake. And here we have our finished project. As you can see, it's super marshmallowy and soft on the inside. It's crispy and a little bit browned on the outside. I covered mine in whipped cream. This is actually the second cake I had to make. The other one had strawberries. This one does not. But either way, it is this delicious, perfect summer treat. It is light and fluffy and sweet, and it just melts in your mouth. And I would absolutely recommend anyone who wants to try making this to go for it. Anyway, thank you for watching our video, and have a great day.